Hey, Uzi, it's time for Sambai Speaks.
I know we're back, episode 7.
Episode 7. We're so happy. And we are so excited to have one of our sister teams or brother teams, but I say sister teams, with the Cancer Grand Challenge, right? And so we have our team Prominent. And so we're so excited to talk to them and share how they are advancing cancer science like we are. And so, when I sit in these rooms that are at these meetings that we have, you guys, we got 300 brains in the room. You can just feel the power and intensity of this thinking and all this thought around cancer. So we're so excited to have you guys on to talk about what you're doing and share with our audience. So Dr. Kim, who are you and what do you do? We're so glad to have you here. I'm so happy to see you.
Yeah, well, thanks for the invitation. We're really excited to have this opportunity to engage with Team Sambai. I will admit that when I heard about the short list, I immediately started talking about Team Sambai in our own team meetings. Like, I think there's a team that we might be able to collaborate with. So I'll just introduce myself and then have the team members who are here with us introduce themselves, and then we can talk a little bit about what we're trying to do in Team Prominent. So my name is Kim Rhoads. I am the Associate Director for Community Engagement at the UCSF Cancer Center in San Francisco. And I lead a number of community partnered and patient advocate type teams. But I also have the role of matching scientists with community partners and patient advocates to do research together and to facilitate some bidirectional learning. So I was so excited when Alan Balmain asked me to join Team Prominent. So on the team, I serve as the patient advocate lead. But in our strategy, we tried to put together the future leaders and the patient advocates to start to work together to look toward the future of what scientists really should be doing, which is understanding what patient concerns are and what real people concerns are, so that the science gets designed in such a way that whatever we learn from it really can be shared and impact real lives. So with that, we have 2 of our future leaders in the room. Hopefully we'll be joined by one of our patient advocates as well. And so want to turn it over to Mariya and then to Michael to introduce themselves and their roles on Team Prominent.
Hi, my name is Mariya. I'm a postdoctoral researcher at Stanford University. And first, I would like to say thank you it's such an honor to be here. And I think it's very important to have these conversations when we can share our science in more open format. I think it's a very great initiative, and I really enjoy your team and the research you do. So I'm a medical doctor by training. I did my PhD in proteomics and mass spectrometry. I'm working at the team of Professor Emma Lundberg now at Stanford, and where we are looking at proteins, basically how they expressed in tissues and in cells. We are looking and trying to understand how these proteins are changing between different diseases, and particularly in Prominent, how they're changing between cells that look normal, but potentially can harbor some mutations and can be promoted later into cancer. So I think that's important to look into the prevention. And that's one of the questions that unfortunately kind of being overlooked, where we are focusing on in our team. And I think Michael.
Yeah, happy to take over. So I'm Michael, currently based at IARC. So this is the International Agency for Research on Cancer, so based in France. But you can tell from my accent, I'm not French. I'm from the UK, where I did my PhD at Imperial College. And, oh, there we go. Currently, I am working on these Prominent and some other projects, specializing more so in kidney cancer, but mainly within these projects, also engaging with the patient advocacy. So it's really a nice opportunity to be here and talk with you guys about a bit of what we do, what we aim to do in the future, and to hear as well from your project, what you guys are working on. Because I also shared in this excitement when it was announced, when you guys first came on the scene and described the project. It's very exciting to see. So yeah, thank you for the opportunity.
Awesome.
And I think we just had Lluvia just arrived and is one of our patient advocates. We're just doing quick introductions before we kind of get going with our with the podcast with our collaborators from Team Sambai.
Yeah.
Sure.
Turn your phone sideways. Turn your phone sideways, and then we'll see your beautiful face. There
Better?
you go. Yeah,
Okay.
that's much better. Right.
Perks of living out in a rural area. In any event, hello, good morning or afternoon, evening for some of you. My name is Lluvia Del Rio. I proudly part of Team Prominent under the guidance of Dr. Kim Rhoads. I mean, how much do you want me to share? I mean, I could go in a lot of different directions.
You want to share your story? Are you a patient?
Yeah.
Yeah.
So,
So what's your story?
And I began this journey in this type of work in about 2018, a year after I had a cancer diagnosis. I was a new mom, and I'd been feeling tired. My work at the time was very demanding. I worked in agriculture, the town I'm from, the whole county. Our economy is agriculture. It's known as the salad bowl of the world. We feed about 80% of the leafy greens that are consumed in the nation.
Where are you?
I'm in Monterey County.
Okay.
In Salinas. So, it's not San Francisco, but to give you kind of an idea, we're in California.
Okay.
Our nearest larger city is San Francisco. As I was saying, some areas are remote, they're rural. 86% of our population is Latino, undocumented. Also living is high. But, going back to my story, I hadn't seen my doctor for a while, and they just couldn't really pinpoint. I knew something was not right in my neck area, but I did end up having a thyroid cancer diagnosis, which was a late diagnosis, or it took much longer than I would have liked for it to take. I feel I did my part, right? But I really had to advocate for myself, right? Coming from a, really traditional Latino family, even my family was like, you're not sick, you're making up things, you're fine. But I really did not feel good. And even like that, I felt like while I did have a support system, my symptoms were kind of also being disregarded by my doctor and my family, when really I knew how I felt, right? Thankfully, thyroid cancer is a very slow growing. I had a non-aggressive type, but then it really got me to think I had access to healthcare, right? Healthcare-ish, right? I had the ability to take time off of work, right? I I knew kind of the things to look out for, and then I thought, what about the population that doesn't have that access, that can't take all that time off of work, that has to still keep on going, right? That could dismiss their symptoms. So at the time, there was some work being done in the county that was planned, right? With the office of the governor and some of the major universities, Stanford being the closest one here. And it was a push for precision cancer care. And so I was invited to a would-be board. The grant had just been submitted. Didn't know if it was even going to happen or not, but essentially it took a year for the group to get the yes, and that's how my journey started. Through pandemic, that was essentially a time where I was able to get more involved, and the efforts, then I started to see more. I started to see more how underserved populations, they're already at higher risk to develop illness, but how they weren't being served. So that only, allowed me to kind of like, work in this type of effort within my community. And I'm from Salinas, so that's like the largest town within the county. But then, there's also remote areas that, there's literally a lot of residential area that's surrounded by fields. And, fields, they're no longer sprayed with helicopters. Now they're sprayed with drones. But the risk is still there, right? And I remember telling my group, like, both my parents worked were field laborers from like the 80s to like the early 2000s. And for all those years, my dad, from about his knee down, his pants would develop these little tears from harvesting. Their fingertips would develop these cracks that no matter how long they would wash or clean them, it's still dark, and it wouldn't go away until the season was over in about November, and they would occasionally take some time off, but even so there was still work to be done, whether it was like working on irrigation or setting up. It was still field work, not harvesting work. So in any event, I left my career that I love so much. And, I started to look at this as like, my gift to the world. With that being said, like, I've learned so much with Team Prominent. I'm going to say it now, and I don't even think I've ever told you, but, Kim has really been a blessing in my life. And she's been a blessing in my life. And she is, a blessing to the communities that she serves, because, the type of work that she's doing, that we're doing, is ultimately is going to save lives, does save lives. There's so much, sometimes even like, with your basic screenings, like colon cancer, there's people that just don't want to do it because they have ideas that, are just these ideas, whether they're cultural or fears they may have. But, I think, the natural next move, right, would be, there's things beyond our control that are in our environment, in our food that's consumed. But, I would really like this to move into, eventually, granted that the research could guide us towards that, but policy work. I could tell you from my experience, how our food is grown. It's pretty scary. Going, just starting from like how the seeds are treated with GMOs, our water, nitrates in the soil, in our actual water. So it's just, I think that's where it starts. And, we could do all this type of work, right? And want to, hello, you there? Okay.
We lost your face. Come back. But Lluvia, wow, you've opened up so many pieces of conversation.
Just touching on so many things that our project is actually for the environment. It's huge project. You don't think about people I at least did not think about people and families in her situations in those environments, and what they might be exposed to and how that relates to possible diagnosis.
Yeah. So Kim, what's the essence of the project of Prominence? Like, what is sort of your overall objective,
So our challenge is about what we call normal phenotypes, and I guess I would say in more simplistic terms, it's just asking a question: how do normal cells stay normal? But what we're really trying to look at is the transition from normal and what that looks like to to malignancy.
Okay.
But we're asking a question about, I think our traditional paradigm for cancer causation is that a cell becomes mutated.
Right.
That's kind of the
normal cell gets screwed up. Right.
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 But in a previous grand challenge that included some of our current leadership for Team Prominent, and that team was called Mutagraphs, what they discovered were some chemicals or some exposures that we know cause cancer don't necessarily leave a mutational signature. And so the question becomes, well, if it's not about mutations by themselves, what else is there that might be driving it? And so I think one of the good, easy to grasp examples of this is this idea that we are all full of mutations right now.
So
all of us.
Mutation? Step back for a second. What's a mutation? Can we explain that?
Sure. So actually, why don't I ask Michael and Mariya to kind of give some of the examples, because we spend a lot of time with the future leaders interacting with the patient advocates to answer precisely these questions. What is DNA? What is a mutation? What is cancer? And that then lets us get to what is cancer promotion. So I'm going to kick it to maybe Michael to.
Yeah, sure. Yeah, so essentially, within all of us, we have our DNA. So this is what you inherit from your parents. It dictates how your hair is going to be, the color of your eyes, everything about you. And from birth, all through the course of your life, this DNA can change. It can get mutations, but typically your body does repair these as well. So you can imagine that a mutation is simply an error in this code. So when the DNA replicates, a cell divides as you grow, this DNA, there can be mistakes in it. And these mistakes are mutations. What Mutagraphs, this project, was looking at were these patterns of mutations that can be present in someone as well. So when we really talk about something causing a mutation, it could be someone smoking tobacco and the smoke causes mutations. There's also these things that we're investigating in Prominent that don't necessarily cause any kind of mistake in the DNA. It doesn't damage the DNA, but somehow it's causing the cancer, or it's increasing the risk of the cancer.
Like the chemicals in the grass and the water.
Exactly. So even, in this example, it could be, typically things in like pesticides. It could be some things that are actually naturally occurring that also can cause damage to our DNAs. They can increase our risk of cancer. But a lot of the synthetic things that we're experiencing in the world now, in drinking water, so many things that can also have this effect. But we don't know it all. This is also the institution that I work in is trying to define these and also trying to do some of this policy work to put limitations on these. So the producers that are putting some of these things out.
Wow. That's
we're effectively trying to push against this idea that mutations alone are the cause of all cancers. That's really what we're sort of pulling it back to, because what it allows us to do is think about whether or not there are combinations of a certain kind of mutation that somebody has being exposed repeatedly to a promoter, some of which we have identified as external factors: Teflon coating on pans, Gore-Tex in jackets, forever chemicals in plastics. Hot drinks is another thing that we're looking at, specifically latte, like super hot, ultra hot drinks. But the idea that there are specific exposures that are kind of looking for, is my mutation here? If I find my mutation here, I'm going to cause that cell to grow out of control.
Yeah. Interesting. Really, really interesting. So are you guys global like we are? Like where are you doing your study?
Mariya, do you want to comment? Because I think you're the most global of our team. You've been in the most countries.
Our team is located in 2 places, in Sweden and in Stanford, in California. I started my postdoc in Sweden, so we have part of the team there, and then I relocated to Stanford University. But basically, our team is across the globe. We have representatives in France, we have representatives in UK, we have also representatives, I think, in 3 or 4 places in US. It's in California, it's in San Francisco and Stanford or Palo Alto. And then I think there
We
are
had Duke, we had Duke, but not so much anymore. And then Spain, of course, in Barcelona at the Institute for Research there.
Very cool. So how are you, so just to make, so like for our study, I can only speak to, and you know, I'm not a scientist, I'm a marketing person and advocate, but for our study, we're actually taking a blood draw of patients and then studying that sample, right? Or collecting 40,000 samples. So what are you guys doing a similar thing, collecting samples from patients, are you engaging with patients? How are you doing that work, part of the work?
So a lot of the samples actually came from the first team, Mutagraphs.
Okay.
And they traveled the globe collecting tissue from both very near to the tumor and the tumor, because they were looking for the mutations in the tumor, but they also took samples of normal tissue. And that's the tissue that we're studying and working on.
Got it, the normal tissue.
Correct.
Normal tissue in a cancer patient.
In someone who has been treated for cancer, yes, or is undergoing treatment for cancer. So those biopsies or large samples came from patients. But we also have a couple of other projects where we're getting tissue from other types of sources. And Michael, I don't know if you want to talk about Brazil, because our pathology focus is in France and IARC, and Michael works with Banush, our pathologist. So maybe you can speak to where we're getting other samples.
Yeah. So basically, this specific like sub-project that's happening in Brazil is quite interesting. So this is with the idea of really digging into this this phenomena that we're seeing of air pollution. So the idea that air pollution in itself can be something that increases a risk of lung cancer. And Banush, one of our colleagues, she's basically gone to Brazil and is actually taking samples from autopsy studies, so people that have passed away from any cause, and seeing how within this specific city where there is very high air pollution, I believe it's Sao Paulo, but taking samples from them to see if there are these markers of what we can look at and see, okay, this is some damage in the tissue, this is damage in the lungs, that may be something that is on the route to what would cause or develop a cancer.
Wow.
So, yeah, it's currently ongoing. Yeah.
Wow. Wow. Are there specific cancers you're looking at, or just sort of cancer all in general?
We're looking at multiple cancers. Mariya, do you want to talk about some of them, since you're picking the antibody markers for all the proteomics? And I don't know if you said you're doing what you're doing, but
we are working with the 5 major organ sites at the moment. It's kidney, then it's esophagus, colon, and pancreas.
Okay.
And this is quite an interesting diversity of the organ sites, because all of them have very different cell populations that we are trying to visualize and see and study. And also there's a lot of processes and a lot of different environmental factors like diet, and then some pollution, and then physical.
Live where Lluvia lives, right? Right.
Yeah.
Difference. Yeah.
Exactly. That can basically influence states of these cells. So it's very important for us to not only look into different cell populations, but also different states that these organs can go into.
like before they become cancer?
Yes.
Yeah.
Mariya, you mentioned the word diversity, so that makes me wonder also, other than cancer sites, how diverse is the study race-wise?
I think we have patients from many of countries. Maybe Michael can comment on that with the diversity aspect.
Yeah, I think in terms of our samples, really they're coming from, at least Mutagraphs at the time was, I think, 11 different countries across the world. There was a lag, I think, in terms of getting samples from the continent of Africa. But in terms of North and South America, Europe, it was diverse in this sense. But yeah, there is still a long way to go, which is why I think when it came to your project, it was very interesting to see, okay, this is a need that's being addressed. But we do have these ongoing collections. So at the moment, I don't know if they're necessarily attached to what we're looking to do in Prominent, but within our team, on some of these projects, we're still contacting new centers, new countries, specifically to investigate the cancers that would be of interest to them. So in the case of something like colorectal cancer, going to other areas where, okay, this needs to be addressed, or maybe it's a high cancer burden. So high incidence of these cancers, and really trying to get more samples from that. But really the spread was more in terms of whether a country has a high incidence or a low incidence, and basically trying to see how that is different in terms of what's happening in the patient, what's happening in these cells.
Right, in the different environments. What about age? Because, you know, Black people are getting cancer so much younger now. Everybody, actually, in breast cancer, the fastest growing group of incidence is now young women, already under 40.
Yeah, so I don't know what the what criteria were set forth for mutagraphs. And I would say that there are a lot of, I would say, more lax kind of ethics allowances in outside of the United States. I mean, for us, it would be 18 and up.
Yeah.
But most of the tissue samples did not come from the United States. So I'm not sure about that. And then, I mean, obviously, mutagraphs was focused on people with cancer. So
right.
The majority of the samples are not going to be coming from people who are under 50. Michael, I don't know if you know, and the reason we're pointing to Michael is because IARC was involved in the mutagraphs project, and I think served as a hub for kind of handling the tissues and the tissue bank.
Yeah, so exactly. This is with our criteria, really just in order to enroll someone onto this, they just had to be over the age of 18, and basically presenting with one of these cancers that we're interested in. And they had to be treatment naive. And that was basically it. So there is a possibility that you can have someone really, well, quite young. I think it would be rare within our cohort. But it is definitely possible. I think it may be some enrichment for some of these cancers that are becoming earlier and earlier onset. So exactly like colorectal cancer.
Colorectal.
Yeah. In which case, yeah, there are new collections that are trying to be started where it's really looking in young people, even children. But yeah, the ethics around this is a bit difficult to get through, and it's
Yeah, you don't want to hurt the patients, you know.
Exactly. And especially with something like Prominent, where we're looking at tissues, how do you justify getting a normal tissue from a healthy child? It's
I know, I'm a healthy child. I know.
Yeah, and we're not collecting any pediatric tissues now, but one of our work packages is actually intervention studies and evaluating the same kinds of questions that we just described about, you know, looking in the cell for mistakes or mutations, and then exposing to different promoters. But one of the promoters, or I guess two of the promoters we didn't really talk about, is obesity. And then smoking, we know, causes these mistakes, but we also think that smoking may have promoters as well. So you're getting the mutation, plus you're getting something to drive it forward. And so we have.
What do you mean by that? What do you mean? So within the smoking, there's something else that's exacerbating a potential cancer?
Correct. So there's a whole list of chemicals that can cause cancer, or known to cause cancer, have been labeled as cancer causing by IARC, where Michael works, because they're the ones who tell us what's cancer causing and at what level of evidence we have. But there are a whole host of chemicals in cigarettes. Some of them cause mistakes in DNA, make the cells not operate or function normally. And then some of those chemicals don't cause mistakes, but we know that they cause cancer. And those are the ones that we think are the promoters, that they're not leaving a fingerprint about the fact that they were involved in driving the cancer. They're going to leave all the blame to the mutations.
There's no trace.
Right. They don't really leave a trace. So
I'd never heard the word promoter before. I feel like it's something a little Gucci and that's pushing the cell over the edge into cancer, right?
That's right. That's a great way of thinking about it. The other one is obesity. And you've seen in so many studies, especially around young onset, early onset colorectal cancer, that we keep pointing to obesity. And so we do have two clinical studies in one of our work packages at Imperial College in the UK. And I think they have one other location in the UK where they are in Manchester. They're recruiting people before undergoing obesity surgery. So then they have the surgery, they lose weight, and normal tissue samples are being taken from a number of different tissues in those studies. So from the GI tract and the rectum, I think they're doing cervical swabs. Are they doing endometrial biopsies? So there's actually a lot of normal tissue that I remember when we heard the list, we were like, in America, you would never be able to do that. But it's going to create a tissue repository that can last over the long term. If any of those folks develop cancer later, you could go back and look at the progression across obesity, weight loss, maybe back into weight gain or not. But we have that, then we would have sort of a longitudinal snapshot in a way to start to understand the transformation of the cells, or if there were any signals that were there in advance.
Well,
And if having obesity surgery and losing weight reduces the risk, right? That's really what we're trying to understand.
So many complications. But so just a question, I'm just trying to understand in my head. A person like me who's had cancer, I have healthy cells. Hopefully I don't have any cancer cells in my body. Are my healthy cells different from Uza's healthy cells who's never had cancer?
I mean, most of the time, even different patients who had experienced cancer, their cells are different. There's so many, again, diversity between every patient. And then we see the differences, of course, between people who never experienced cancer before and people who did have experience.
That's my question. Yeah. So you look at the people who have had cancer before, their healthy cells, to see how you can prevent.
So basically that's one of the main questions that we want to see, whether we will be able to identify these types of cells, whether there is based on the different shape, size, protein expressions, or some mutations that already accumulated. And then we'll be able to basically trace it back and see whether those cells can also appear in the healthy individuals.
Right. Wow, so complicated. So another question just for clarification. So Lluvia lives in this neighborhood where there's a lot of stuff going on, right? With the drones dropping chemicals and all that stuff, right? And I think what we're seeing is that people get cancer from wherever they get it from. They go to the doctor, they take the chemo, they do the stuff, they get better, their cancer, whatever, they have no evidence of disease, which I hate those words, but then they go back and live there again. So what happens? They have a recurrence, right? I mean, that's what kind of we're seeing in our exposomics work for Sambai. Like in New York City, these people are living in New York City, exposed to whatever they're exposed to. They go to Will Cornell, they go to, the hospitals. My dog is snoring. Can you hear that in the background? But they go and they get their treatment, and then they go back home.
Yeah,
and that's their home.
And I think, but here's what's tricky. There are so many different factors that are contributing to the development of cancer that it's unclear. So they go back home. In our scenario, the promoter is looking for a specific mutation. So they go back home, they've got lots of mutations. They might not have the right promoter and the right level of additional exposures to drive another cancer in their lifetime.
Right.
But part of what we're doing helps us to understand is, how do people who don't smoke, like our other advocate, Floyd, turn up with a lung cancer?
Right. We have so many of those examples too, where I didn't smoke, but I got small cell lung cancer. Hello, right? So where did it come from, right?
And that's I think that cancer promotion, and there's already actually been a paper published by Charlie Swanton, who is now kind of the lead of the Grand Challenges. And dare I say, he was influenced by Team Prominent.
You can take the credit, go for it.
He was in our review, and I remember there was a lot of back and forth, but he really carried out the full set of experiments in mice by exposing them to pollution, mice that had existing mutations versus mice that didn't have existing mutations. He did see an impact of pollution, and then they start to look in the cells and think about mechanistically what's actually happening. And it looked like there was some mediation through inflammation. And that starts to, at least for the physicians, for the surgeons, right, start to help make some sense out of things, because we know that, and I didn't say I'm a surgeon by training. I'm now retired. I don't operate anymore, but I've operated on a lot of cancers. But we also have this phenomenon called a Marjolin's ulcer, which is a wound that does not heal. And chronically over time, it's not healing. It just keeps not healing. Once you get to about 15 years and you take a biopsy of the edge of that wound, you will find malignant cells there.
Wow.
Right. So that inflammation, as it's trying to heal, it's making the cells turn over, right? Like when you're making a scab, that cell's turning over, becoming a scab. The scab peels off, then collagen comes back, you get your skin back. Like that's all inflammation. And that process is ongoing. And because a lot of cells are turning over at that time, there are opportunities for mutations. There are opportunities for specific clones or cells that have a specific mutation to replicate. So what we're trying to get at is so basic and fundamental to our understanding of how cancer starts. That's why it's so complicated, because there's so many factors. It's not just the promoter. It's not just the mutation. It's the environment around those cells. There's so many different pathways to developing a cancer. So for the person who goes back to where they live, you've got to have that combination come together again, like lining up Swiss cheese, right?
Right. We have one of the aspects too of our study, Dr. Shiba Ershad at Guy Cancer Center in London. She's not only studying like sort of the cell differences between black and white TNBC cancer, but she's looking at the immune systems and how our immune systems are so different, could have a huge impact on how they interact with the cancer, but also how they interact with the drugs, the treatments, right? So that's a whole nother thing to think about, how are these factors affecting your immune system and their ability to like get rid of the cancer, right? Gosh.
Exactly.
So many things.
Yeah.
Michael's laughing at me. He's laughing. Are you laughing?
No, not at you. Just I think it is very interesting. I think it's just there's so many factors that we constantly have to think about, like in terms of our research, how we put together our projects and everything like this. It's like there's this that you've just mentioned. I kind of do think of a paper that I read recently that was looking at like it was a bit about life expectancy, mortality, and also the risk of getting any kind of disease. And even these factors of like even just ethnicity and these things that are actually mental or socioeconomic, like they all play a part. So really like getting this combination is it's a lot to unpack.
That's why
and that's a soundbite. Go ahead.
I was just gonna say that's why it's called the Grand Challenge, because there's so much to tackle. so many unanswered questions. I have a question though for the advocates. Different project from us. So what does advocacy look like in this project? And Dr. Rhoads, you wear so many hats. So what does that look like for you here?
Yeah, I'm gonna let Lluvia jump in. You want to say, what does advocacy look like in our project? What do you feel like your role has been?
Yeah, sure. Well, absolutely. I think it starts from education. So in my work outside of team prominence, I just feel we're always doing a lot of things and like because our heart is in it. But just last year, we sat down and we planned a whole campaign that is only surrounded I mean, we're still going to do all these wraparound services, but really making our main focus education, but education in breast cancer, cervical cancer, colorectal cancer, lung cancer, and prostate cancers, because those are the cancers that like you could screen for. We could get our patients screened for, right? And, you know, we could somehow follow their continuum of like care. So we, you know, like, you know, sometimes you try to do too much and then you don't do much, right? So I thought, okay, we're just going to focus on these 5 cancers that, you know, screening is fairly accessible to, right? And then work from there. My first language was Spanish. So, you know, also focusing on that population that, you know, does not speak anything besides Spanish, that, you know, is undocumented, and maybe they're afraid, especially now we're seeing that a lot of people.
What's going on in your neighborhood? Of 85% of.
Yeah. So for example, we have experienced a 3-fold increase in calls to our call center. Just because people now don't want to go to the doctor because somehow they're going to be tracked. They qualify for Medi-Cal because we are in California, but they do not want to use their Medi-Cal benefits because somehow they're going to be tracked. So right now there's like this, like, you know, there's a lot of fear that is in our people, and it's getting trickled down to their kids. So not too long ago, my son was like, you know, my best friend's here now, but he may not be here for a long time. So, you know, I need to I want you to help me to make sure to keep in touch with him when he goes back to Guatemala.
Wow. Oh my God. How old is he? How old is he? And he's worrying about this?
So they're like, it's like really big issues that, you know, you really have to be, you know, really living it or in the community to understand. But going back to the real question of, you know, that's how advocacy work is looking for us, really educating people. But now we have to have that added layer, like, hey, everything's gonna be fine. And I tell people, you're in California, you were anywhere else, somewhere else, it'd probably be different. But I mean, we're a sanctuary state. Monterey County is a sanctuary city. So, but that still doesn't take the fears away.
Yeah.
It doesn't take the fears away. I mean, I could, like, I'm not shopping at Target right now.
Hello. Right there with you.
Because my honey refused to get the Starlink internet. Yeah, so, you know, just all these things, like, we're like having to, like, you know, like our life is, you know, just taking a different direction because of where we may be at these for the next 4 years.
Well,
But
that alone without cancer is bad enough. Add cancer to top of that. Oh my gosh. Right.
Exactly. I was just so I visit an herb store, and so I've been going there for a long time before I even had cancer. And the gentleman there and his sister who run the store were telling us the same thing. Like, we're seeing a whole lot more people like coming into our store and getting the remedies here because they kind of like, and how like they're just kind of like, they want to become invisible because they're afraid of what may happen to the patrimony they've built here.
So how do we do research in this environment? Like, so first of all, when did you guys start your study? You guys are like 2 years.
No, we are in year 4.
Oh, in year 4. Wow. Okay. Okay.
And actually, we had an advocate from Monterey who Lluvia works with, but then he got pulled into another advocacy activity. So Lluvia joined us, I think, in year 2. And to respond to this question of what does advocacy look like, you know, when we went to our summit that year and Lluvia came, we were in London, and we have our, you know, our team meeting to kind of go through the slides and what the scientific review is going to look like. And Lluvia whispered to me, I have a question. And I was like, well, what's the question? And she said, why do people who smoke a lot of cigarettes not develop cancer? And I was like, oh, you should say that. That's amazing. And so she brought this question into the space, and the senior people were like, no, we can't look at that. And the future leaders were like, yeah, we can look at that.
Yeah, look at that. Oh my God.
Well, because again, so what for me, you know, writing the part of what the advocates would be doing, my holy grail is the questions come from the advocates, and we actually develop some science around the question.
Right.
And so because we came out of mutagraphs, prominent was delivered out of the scientific minds, if you will, right? So the patient advocates on mutagraphs, I would just recommend you read what they wrote at the end. But I met with Mimi and Maggie. They're very wonderful, lovely people who run these wonderful organizations around pancreas and colorectal cancer, I believe. And they just didn't feel integrated, I think, into their team. So the approach I really wanted to take was integrating the advocates' voices, however they get delivered, right?
Yeah, that's what
So
we're doing.
when Lluvia delivered this question, we had a big debate, and it was a lot of fun because I loved to see the future leaders thinking, oh, I can put my mind to that. There's a way that I can think about answering that. We might not get the answer, right? Because it is a grand challenge. So that question has permeated our every team meeting. It comes up every time.
Yeah.
And so now we are in the process of, our team has set aside pilot funds. So the future leaders are working together with the advocates to actually develop a research study using each of the different technologies from their lab to contribute to starting to investigate this question. And so we had a meeting this morning. And one of the things that came up, which I thought was really cool, is there are some methods and approaches to answering this question in some of the labs where the advocates could actually come into the lab and do some of the experiments, or do parts of the experiments, or help with the tissue sample collection. So for me, what it looks like is regular people being very fully integrated into the process of developing the questions and helping to interpret the answers. So that's where we are.
So we're breaking it down, bring it down. I think we also kind of say we put the hug around the science. So bringing some love to these conversations and saying, like you just did for Lluvia, saying, no, we are going to answer her question. Because
we're going to try. We're going to try.
Right. Wow.
It might be interesting.
The importance of keeping us at the center of it, because these questions, come up so naturally. Some things feel like second nature to us and not necessarily to the science brain. No offense to all of the doctors we have on here, all our researchers, but we get so wrapped up in the science of it all, and it's important, obviously, but remembering the patient is a person is also equally important here.
We're doing it for people with cancer, right? Because we don't want to get it.
Well, I was going to say, that's what I was going to say, is that our project, and I've really been adamant about this from the beginning, that because our project is about normal tissues, it's actually about everybody. I mean, most of the other projects are working on cancer. We're working on trying to prevent it. And I don't know if you can see our little tagline here. Is,
I love
stopping cancer. And then team prominent on.
Yeah. I mean, us too, like we're going to take your blood draw and we're not going to be able to impact your cancer. We're worried about your grandkids, your kids.
Right.
That's the whole purpose of the challenge, I think, Wow.
Yep.
So are you entering into your year 4, entering into your year 5?
We're entering into year 4, but I think we're probably going to be on a no-cost extension.
Okay.
Because we still have more to do. Our year 5, year 4 and year 5 is really about integrating all of the different labs, because we didn't even talk about the mouse studies, which are really looking at using chemicals as mutagens, making the mistake, and then another chemical as promoter. So we can actually control the time between you've got a mutation and are you going to develop a cancer, or are we going to drive that cancer forward with a promoter and can very clearly see mice sit with mutations for months and months and months and nothing happens. Nothing happens. And then you promote it and something happens. So we've got that mouse work. So we're trying to integrate the mouse and the human side of what's happening. And then also we're sort of debating, should we take it across, like take one cancer and do it across the whole continuum to show the entire spectrum of this idea of promotion with snapshots, you know, with the spatial proteomics, or like mapping out where the proteins are in the cells. And then also in looking at trying to block what we think is promotion. That's another work package we didn't talk about.
So
and then the
that.
clinical trials. Oh, the CRISPR part?
Yeah.
I don't know if Mariya or Michael can talk about CRISPR. I don't feel qualified to talk about CRISPR.
Yeah, I mean, it's basically just changing different genes, the ones that we already talked about. And if we are able to find something that is expressed in the cancer cells, and we are able to just make the expression a bit lower or completely turn it off, and then test different chemicals and see whether this will help to either prevent from cancer, from developing cancer cells, or if there is a opposite, if certain genes or certain mutations are able to actually stimulate cancer development. And in these cases, it will be easier because we cannot do that in humans, obviously, but it will be easy in the mouse models because it's the living organism, and also in the cell lines, when you can see that how these cells are changing and different environments that are changing with it. So I think that's quite a powerful tool as well.
Very cool. Very cool.
Yeah, I just wanted to mention about patient advocacy, but our influence of patient advocates on our work as a future leaders. I think it's a crucial component of like grand challenges. And also I felt like it was very important since it's very grounding for us. It's very important to deliver science. We usually talk a lot about science, but in more scientific terms, and it's nice to bring science in more like to more general audience and make it more accessible. I think this is quite important because there's a lot of disbelief, especially in recent days in science, and it's like in the research. And the only goal that we have actually is to make life better. We are not creating scary things in the lab. We're actually trying to understand how these cells interact with each other and how we can prevent it. And one of the, I think, important things about the prevention is actually sharing information to give knowledge to the masses. It's like what you can do to prevent you having from cancer. Because I think it's quite, I mean, in my case, I work in this project that's quite personal because it always comes from the perspective of the patient, from human, that at some point we will be able to say, instead of you have a cancer, this is what you can do to prevent it. And I think that is the most powerful thing, because there is so many lives are being turned upside down when you have this diagnosis, and everything is just crumbles, and there's so much fear. So I think it's the prevention is very important to like stop this fear and stop. We already have quite stressful life, I think, and it's like having this prevention from another very scary event. I think that would be very useful, and I think it's quite important to bring that to the public, and that's why this type of forums are extremely important.
Yeah, I think even being a part of projects like this and working closely with patient advocates, a lot of the times different providers are not connecting with patients on this level. So it helps shape all of you as clinicians as well and as researchers. I think it's amazing.
Well, if anyone could have told me you could do this differently and you won't get it, I wouldn't have done it. Right? I mean, the prevention thing is so huge, and we do screen, and I was screening. I mean, I think that but like things like prostate, we can screen for. I mean, and we can screen for colon, we can colorectal, we can screen for that. So just even educating people about that, and if they can see what you're doing and see the impact of what you're doing to prevent it, is such a great, you know, it's something you can't even ask for, because, you know, as a survivor, I mean, as a patient, we didn't know we were going to get cancer. Weren't you shocked even when you got cancer? Like when you got that call, you got cancer, like you're shocked. Like, how this happen to me? You know, like you're not thinking about cancer, and all of a sudden, bam, you have cancer and you're going to die. You know, like it wasn't even on my radar screen, right? Even though I had 3 generations of breast cancer in my family, still, it's a shock.
You
Right?
cannot ever prepare yourself to have this diagnosis, no matter
Yeah.
what, because it's still, there's a lot of stigma around this diagnosis and a lot of unknowns, like how can I plan for the future? What should I do with this scary event that happened to me? And it's like, and also I think there's a lot of fear about the future generations. If you have kids, what should I do to help them to not experience this very scary thing and life-turning event?
Yeah,
And
my daughter had a prophylactic mastectomy last year. She had 3 babies, nursed 3 babies, and it's like, I'm not getting this thing, you know. So if we can prevent it, but I mean, but if you, I'm thinking about Lluvia and her community where she lives, you know, like, you know, how do you change that? So gosh, you guys, there's so much work to do, you know. When we go to these challenging things, I think I see all these brains in this room, like, are we ever going to cure it? Are we ever going to get rid of it? Are we ever going to make it chronic? Are we ever going to make it go away? Like, there's so many facets of it. The one thing we didn't explain, and you guys have been saying a few times, is what a future leader is. We've never talked about that on the show yet. So can you talk about that, like what a future leader is in Cancer Grand Challenge, real quickly?
Sure. I'm not sure if I think we might have made it up, but I'm not sure.
No, we have them too. We have them too.
No, but before Team Prominent, I don't think they were called future leaders.
Okay. So you guys invented it.
They were. So Michael, I don't know. Why don't you go ahead and say what a future leader is?
Okay. I guess within a project, so within our project, the future leaders are essentially the researchers that are not PIs. So we can go from being a master student, PhD, postdoc, whatever. We're the ones that are actually kind of doing the analysis.
Right, you're doing the work.
Yeah, the direction is more for the PIs and the team leads. But yeah, our future leaders, as it is in the title, the intention is for us to lead in the future. That we can go on to be PIs, that we can go on to lead some aspect of this own study or a different study. But yeah, this is the intention of this thing that we call future leaders. So I think it's nice within our project, we do have this opportunity to take the little pilot project and try and like push that forward into something more. Try and take that as our own little slice of it. Yeah.
Which is also what I think is so awesome about the Grand Challenge, is that we are bringing in everybody that we can into this science and helping young people to get stronger and learn and develop and actually do the work. So gosh, you guys,
and to have those future leaders move into their PI-ship, not thinking, oh, I need to check a box with some patient advocates, but like, where are the patient advocates?
Yeah, right. They're growing up with us.
Yeah.
Have it completely normalized, exactly, because then we don't have to keep doing the science the way we do it. We can do science just because, oh, I have a question and I want to answer it. I don't know what the implications are, or hey, I have a technology so I can sequence everything over here. What's missing is, why are you doing it?
Yeah.
And that thing is the patient advocates. That is the missing piece.
Right.
And so every year we're trying to emphasize that when we go to the summit. It's like everyone's a piece of the puzzle and every piece is important.
Yeah.
So
expanding the lens overall. Yeah. Just how we do science and how we integrate people into the science. Incredible.
So we're
and I do want to say we did have one last thing, because Mariya didn't say it. But Baba Gerald, who was one of our original advocates who passed away in 2024, asked a question in one of our training sessions, because we host the training sessions for the advocates are led by the future leaders. And one of the questions that he asked led to, I think, one of the antibodies or 2 of the antibodies that you selected for some of the experiments that we would otherwise have not been using. So we're really knocking on the door of
Yeah.
the science.
Real people, the real stuff. Well, thank you. We're grateful for you guys.
Thank you so much. This has been amazing.
It's so great. Learned so
Thank you
much.
for the invitation.
And you know, we'll air this and we'll come back to you soon and we'll do this again. You know, we got a couple more years of Sambai Speaks to go and we'll come back and do it again, see how you're doing, see how you're progressing. And you can take care of your people, girl, Lluvia out there. I know. I mean, gosh,
Yeah.
it's a rough life. I mean, you know, just get some good navigators to help the patients, you know, and do this work. But thank you. So we'll see you sometime soon, right? And
Thanks, everyone.
All right.
yeah, take care. We'll see you next month with another episode of Sambai Speaks, right, Uza?
See you guys later.
Thank you. Blessed love. I always say sorry, breast cancer lane. So take care. Bye.
Bye now.
Bye.